Here's a few news articles that might be good. Let me get rid of this nonsense. Okay, autoplay. Anyway, apparently people could look in the sky and see this. And this has happened here and in another town. You see a whole line of stars in a row. And what those are is Elon Musk's new satellites. He launches them like hundreds or thousands at a time. And he gets, when they're reaching their position, they all line up like this in the sky. I see a question: if I'm able to get the OAuth user token, is it a security flaw? And it's not, I think. The broken SSL itself is a flaw, but the whole point of an OAuth user token is that it's not very much to lose. However, broken SSL itself is a flaw. That means that people could man in the middle it and take over one user's session. So that's a flaw. Yeah, we should talk more about that later, show you what you got. And let's see if we can figure out how to present it. Anyway, that's interesting. You're seeing that in various towns. Elon Musk is launching thousands of satellites to make free internet service. Good. And so this one, a student showed me in a previous class or a couple of years ago, but it's pretty awesome. As you've been talking a lot in our Android class, the Android security is really, really bad. And one reason is that people just copy and paste code, and they copy and paste it from the same source, pretty much Stack Overflow. Me too, that's the easiest way to get code. And they've shown that tons of the security flaws just come from reusing code, often with a security flaw. And so the end result is sort of like a supply chain issue where a library that many people use is vulnerable. Here, a source of code that many people use is vulnerable. So we're talking about all electric cars very soon. This is really soon, 2030, less than 10 years, all electric in Europe. So let's see, I know that I'm catching up, so I need to know if I can use a combination of projects and CTF challenges. Well, I don't have CTF challenges in this class. There are no projects at all in this class. So, and in my other classes, 123. You should talk to Elizabeth about that. And I think the answer is yes. But she's the one to talk to. Okay, good. Yeah. But I'm sure the answer is yes. She's told me. Yeah. Good. All right. Anyway, so, all right. Anyway, we may have all electric cars soon. And apparently that's considered a good thing. I always felt like the all electric cars were a problem because I wasn't sure they actually saved energy if you include the full cost of generating the electricity. But I've heard some experts say it does, in fact, have lower carbon. So that would be good. Anyway, this thing I thought was pretty awesome. You don't have to do the presentation live, no, if you made a video. You can just turn in the video in Canvas and we'll look at it. Or you can just point it out to me here and we'll look at it. Good. Good. See, that's some good questions. I see people have presentations. You still have to dig for the, well, that's true. I mean, well, generating, building a car costs something, Anyway, they say that the electric cars are decreasing the total amount of carbon. Some experts are saying that. That's an interesting issue. Anyway, so this one I thought is pretty amazing. You can make an air purifier just for about $20 from stuff from Home Depot. You just take an air filter and you stick it to a fan and blow the air through the fan. And now you're putting all this through a filter, which is sort of like a face mask. And that's going to remove some portion of the particles from the air. And he has some scientific analysis that it's probably going to get a lot of the significant particles. So putting one of these in your room would probably make it safer. So that's kind of cute. All right. And so let's get rid of this stupid autoplay garbage. So this is an interesting administrative issue. A lot of people are not showing up, 10% of them, adding up to thousands of appointments. 4,000 people with appointments in Santa Clara did not show up. And they wonder what's going on here. And the answer is incredibly simple. I was just talking about this with one of the other classes. We don't have an intelligent system to put people in line here, which is amazing. There's not one place where you sign up. There's not one place where you get a number. They don't service people in order. So the result is people don't know what to do, so they sign up at many places. Then when they get in, there's a bunch of appointments at the other places they won't show up for. It's so this is a sign of poor management. I mean, we don't have any organization with our management here. I don't understand in America why there is not one central place you sign up, like one national website where they just mail you a number in the mail that is your number. I am number 10,040. We have now served up to 1,000. We have served up to 2,000. Then you would know when you're going to get your vaccine and how far away it was, and you'd know that other people aren't jumping ahead in the line and things like that. It is amazing how far we are from that. Haven't even done it at a state level. There's just all these different people handing out vaccine randomly. And so if you're vigorous enough to hunt for many websites and sign up for them, you get it earlier. And if you're not, then you don't get it at all. This is very crazy. We're scrambling to figure this out. Well, we are, but I don't understand why we're scrambling to figure it out. Every deli counter figured it out years ago. You just give everyone a number and put them in line. It is very strange. We have nobody in charge and no organization. This is what happens when you have no management and no government. It's just crazy. There are many ways to do it, and we just don't seem to have anybody that makes a decision. Yep, there are many possible solutions. You could let Amazon do it. You could let CVS do it. You could tell everybody with a health plan that they have to go to their health plan. That would seem reasonable. But we're just randomly doing everything. It's very strange how we don't bother to organize it at all. And this, I think, is pretty amazing. They're suing Trump on the anti-KKK law, a House Democrat. The anti-KKK law came in after the Civil War because the KKK came out and they tried to stop black people from voting. And so there's a special law that if you form an organized group of white supremacists who then prevent black people from voting, there's a special law to prevent that, and that is essentially what the riot at the Capitol was. That was trying to force them to disavow the votes of the black people, so I think it's very appropriate. We'll see if it wins. It's difficult with Trump. Yeah, hopefully the new administration will organize it better, but so far the organization is not visible yet. Anyway, all right, so we're ready for the official time here. So let's go to, this here is 125, and we're down to the second of 3 lectures about security engineering, and there may be some students that have early presentations. So that's good. You get extra credit if you do it now. Otherwise, you do it next week or late the week after, your first 4-minute presentation. And you can either do it live in class or you can record it as a video and submit it. So anyway, let's pick up with the slides, which are here. Yep. Oh, yeah, putting yours in Canvas, that's fine too. All right. You just upload it in some form of file and put it in Canvas, that's perfectly fine. So we'll talk about secure operating system and software architecture. So we got the kernel. The kernel is the part of the operating system that can directly touch the hardware, and it runs in ring 0, so it has the maximum privilege to use every possible operating system command, or every possible hardware command, pardon me, not operating system. And there's monolithic kernels and microkernels. The monolithic kernels are not that common. This is where the entire kernel runs in something called supervisor mode, and all functionality has to be pre-compiled in. This is what Slackware used to be. Every time you add new software, you have to recompile the kernel just to add more software to it. So this would only be appropriate for something like an Internet of Things device where you don't change it much. The far more popular kind is the microkernel, which is what we're using on Linux and Windows and Mac. This is a all-purpose operating system where you might want to change things, like you might buy a webcam and plug it in. Then you're going to need a webcam driver in the kernel, and you don't really want to spend 36 hours recompiling your kernel, so you have these things called loadable kernel modules that can just add code to the kernel without modifying all the rest. And the modules might run in ring 3. Now, if you're going to have a computer, modern type, and especially if it's going to meet the Orange Book specifications or the later specifications for security, it has to have a reference monitor. This is the part of the computer's operating system that enforces the security policy. So this is what means if you're not the administrator, you can't perform an administrative activity. If you're logged in as one user, you can't enter another user's account or their profile. That's the point. And so you can't get levels A and B of TCSec without a reference monitor. So you have permissions on files and folders and printers and everything else. In Linux and Unix, they use read, write, and execute. There's 9 bits, read, write, and execute for the owner of this object, read, write, and execute for people in the same group, and read, write, and execute for everybody else. So this thing called APM has read, write, and execute allowed for the person who owns it, who is root, read and execute but not write for people in the root group, and read and execute but not write for others. That's the Linux security model. In the Microsoft model, in the modern operating disk format they use for all versions of Windows now, NTFS, you've got these kind of permissions like full control, modify, read and execute, read and write. And you have groups like administrators and everyone and such. It amounts to essentially the same thing, but the details of exactly how it's implemented are a little different. And something about COVID ventilation, all right, we'll get that later. Anyway, now you can have privileged programs that run at elevated levels. These are called setuid files in Linux. And a file like this will run with the permission of the owner who made the file, even if you run it as somebody else. Because as you saw back here, here's a file that can be executed by the owner, and it can also be executed by other people. Even this X right here at the end means it can be executed by anybody. Now normally, like this ACPI, if I run it, it will run with the privileges of my user account. But if there was an S here instead of an X, that would be a setuid program, and then even though I run it as somebody who is not root, that program runs as root. This is how you elevate privileges, and for example, this is how you change your password. Because to change your password, you have to write to these files, etch password and etch shadow, and normal users don't have the privilege to write there. So you have to have a process that can elevate to root to write there, even though you are not root. And one way to do it is with setuid files. All right, virtualization is everywhere these days. None of the servers you connect to on the internet are mounted directly on hardware anymore. They're all simulated machines. This turns out to be extremely cost effective. So you run a thing called a hypervisor, which simulates hardware. So when your program writes to the hard disk, it's really writing to a simulated hard disk. And you run a guest operating system running on the virtual hardware. Full virtualization is what you might have with VMware or VirtualBox on a desktop computer. This simulates hardware that can be totally different than the real hardware. If you can simulate a different network card and everything else, and the guest operating system runs with no modification. This is the most isolating way to do it, but it's also the slowest and most expensive computationally way to do it. Paravirtualization is where you make the virtual hardware very similar to the real hardware, and therefore the guest operating system can be running more efficiently. You can run more of these on the same hardware. The virtual machine is smaller and faster. And the extreme of this is modern containers, which run an overlay file system and are even smaller and faster, but less separated from the host. So the hypervisor is the part of the operating system that controls access between the guest and the host. You can run the hypervisor directly on the host hardware, and that's what VMware ESXi does. Then you run virtual machines on it. Or you can have a Type 2 hypervisor like VMware Workstation or VirtualBox, where you have an entire operating system underneath it, like Mac OS or Windows, and then you have the hypervisor and another entire operating system on top of it. So this is much more complicated and slower, but much more general purpose. So the reason why you would do this, I remember this all came out in 2014. Microsoft put out a product called Virtual PC, and I immediately got it, and I could run a simulated Windows XP on top of Windows XP. And after I got it running and said, that's cool, I said, why is this even here? What's the point of this? I've just got XP running on XP, and the point is now I could run a whole network of machines, and it turns out to be extremely valuable because servers typically run at only 20% of their capacity. So you could get more value out of the hardware you pay for your server by running virtual servers on top of it, and then you can use all the hardware. It also turns out to be far better to make clusters of machines where all the machines have to be exactly identical. Can I turn volume up? My goodness, it's already hitting the red line. Can other people hear me? I don't think I can turn it up any louder. I see this thing going up to the yellow. What do other people get for the volume? I sound good? Okay, Jesse, you must have some kind of adjustment of the volume inside your computer. Yeah, in virtual. Okay, good. Yeah, because I can see from here I'm hitting the yellow. All right, good. Now, I had to refresh. Good. All right, so in VirtualBox and VMware are full virtualization, not para-virtualization. And okay, I'm looking for any other questions, and there aren't any. Good. All right, so anyway, here's another big issue that saves a lot of money for virtualization. If you have the person from a huge bakery company gave a talk about this at a VMware conference I went to. They had a server farm with a lot of servers, and they were all exactly identical. But then after a few years, that hardware was old, and they couldn't buy it anymore, so they had to keep a closet full of the old broken servers and keep repairing them because the servers all had to be exactly the same to network properly. And after a while, that hardware is old and obsolete, so they switched to virtual servers that ran on virtual hardware, and now the actual physical hardware could be anything, but this virtual hardware was identical, so they would network correctly. So you could have old servers, and then you could buy new servers that are more powerful and run copies of the virtual server on there, and that's much better. And this turns out to be extremely powerful, where the actual servers, the virtual servers that you run are not connected directly to the hardware underneath them. So that's the benefit of it, but there are issues. You can run many guests on one host, but if you do that, there's only one physical computer and you're running several virtual computers on top of it. They're not really isolated from each other. Yeah, this is what the cloud is. The cloud is all running virtual machines. And so since they are really running on the same hardware, they're really sharing the same processor and the same RAM, so there are VM escape attacks that leak out of one virtual machine onto the host and perhaps into another. So it's not as safe as air-gapped machines where they're actually on different hardware and separated from each other, but it's much cheaper. Yeah, containers and Docker are less secure, faster and smaller than virtualization. Yes, containers are even more close to the operating system underneath them and sharing files. Yes, exactly. But containers are much cheaper and faster, so they're very popular. All right, and so another issue is containers and Docker are a system using overlay file system, and they do not make an extra copy of a file in the virtual machine if there is a copy of that file on the host. They both share the same file. So it only makes new files if you put something new in the container that is not in the host. So it is a much smaller, much faster way to run a virtual machine. Docker containers are just a faster version of virtual machines, faster and smaller. That's the point of them. And they share resources like CPU power. Yeah, you have one computer underneath, and you run containers on it. They call them containers instead of virtual machines. But they work the same as virtual machines. They can run a new program and share and connect to the network and serve it, but they are much smaller because they don't bother making any extra copies of files. They run this thing called overlay FS, so they only make another copy of a file if they're going to change it. So if you were to put, say, a Windows container on Linux, it would be the same as a virtual machine, if you could even do it. But what you do is you put a Linux container on a Linux operating system, and most of the files are not copied over because they're identical. So it's just, for all practical purposes, it's just a much smaller, much faster virtual machine. So hardware that could run maybe 4 virtual machines could run 40 containers. But there are a lot of security problems with containers. They're not considered a very strong security boundary. It's pretty easy to escape to the host. Easier than it is with real full virtualization. All right, and another thing you can do, normally, if you want to monitor your network traffic, you find a cable that goes, say, to the internet, and you connect it to a span port on a switch or a network tap that makes an extra copy of all the traffic going through that wire, and now you can monitor the traffic of your network. But if you have virtual machines talking to each other on the same host, they talk to each other, and that network traffic never goes out a real network cable. It goes out a virtual cable to the other virtual machine. So you've got traffic that you can't see. And that's why if you go to the cloud environment like Google Cloud or Amazon Cloud, you have virtual servers and then you have virtual firewalls. Wireshark could capture it if you could connect it to that virtual adapter. And so could things like Splunk or anything else, but you would have to. The same thing happens in a real data center. If you have a lot of switches and routers and servers, there's traffic going all through all different paths, and you have to put in enough devices to capture that traffic to get visualization to it. If you capture packets in promiscuous mode, you would still not see it, because if one virtual machine on a host sends traffic to another virtual machine on the same host, that never turns into a network packet anywhere. That goes out of virtual network adapter, and it doesn't touch any network adapter as far as I know. You create a software synthesized network adapter, and what you would have to do is you'd have to connect to that virtual network adapter. In fact, you can see them on my Mac. Let me bring up a terminal here. I've got a lot of virtual machines installed on this Mac, although they're not running right now. And if I do ifconfig, I'll pipe it to more. Let me make this big. All right. So if I do ifconfig and pipe it to more, all right, I've got EN5 is a real adapter. AP, I think that's a simulated adapter. Then I've got EN18, which is I think also a virtual adapter. And here's bridge. This is definitely a simulated adapter. A bridge adapter is created to connect to a virtual machine running in bridge mode. This LLW0, I'm not even sure what that is. Here's tunneled adapters. Here's VirtualBox, makes these things called VBoxNet. Those are what carries the traffic, and those are not tied to any hardware. They're just software objects that route virtual network packets to other virtual devices. So all these things are used as if they were hardware, but they're not. That's how the virtual packets go. And I see if you, what layer is the VM network traffic? Well, the network traffic will have all the features of a normal network packet. If you can get Wireshark or something connected to it, you'll see everything. It has an Ethernet address and an IP address and all that. See, here's the Ethernet address of the VirtualBox adapter. But it's not a real packet going through a real wire. These are very good questions. All right. And so here, then there's the level of cloud computing. So if you rent a virtual server, that's infrastructure as a service. That's what I do for my, ifconfig is deprecated, but the Mac people haven't caught on board. So you have to use it on Macs. You're supposed to be using IP for like the last 7 years, but IP is not installed on Mac OS because it just seems to be kind of behind the times. Anyway, infrastructure as a service is where you rent a server and you have the whole server. You can install the operating system and the software and updates and whatever you want. Platform as a service is where you don't control the operating system, but you can use it for certain purposes like web hosting. And then there's software as a service where you are just getting to run one program on the server like Gmail. You can't install any software. You can't run anything but Gmail. You can just use Gmail. You're using a software on somebody else's machine. So those are the three general categories of cloud services. Capture packets through Wireshark between two VMs. You could capture it on Wireshark if you could connect it to this virtual adapter. And that would depend on some software decisions in Wireshark, and I'm not sure how it is. You might have to make some adjustments to do that. If you run Wireshark, let me get here because this is a good question. Okay, here's Wireshark. And if you look at Wireshark, here's the adapters, and I can see UTUN3 and UTUN2, and I can see VBoxNet 0. So right there it is. You could sniff on that virtual adapter, and then you would catch the traffic between two VMs. And I don't know what the question means, what's above card level. The levels of packets, the OSI model, there's the IP address level, there's Please do not throw sausage pizza away. Physical, data link, network, those are the levels of networks. And all those are there in the simulated package, except there is no physical level. There's no actual voltage anywhere. You have a data link level and a network level and all the levels above that. All right. Anyway, so you can have your private cloud, which is not the most common. The most common is a public cloud. If you use something like Amazon Web Services, then you're putting your data on Amazon servers, and a bunch of other people are putting data on the same servers, and you don't know how your data is separated from their data. And as you know, there are all these breaches of people that put things on the Amazon cloud, and then it turned out they didn't put the right permissions on it, and everybody can see. Those are the cloud storage bins that people keep finding wide open. And this is the number one concern of people moving to the cloud, is they're worried about security. So this is an issue. Now, if you carefully configure the Amazon cloud, it can be secure. And if you pay more and sign a contract with Amazon, they will even guarantee HIPAA compliance and even enough compliance for supposedly military purposes in the Amazon cloud. And also in Azure, if you sign the right contract, they will promise. For example, Azure will promise that your data will stay in the United States and not be in other countries and things like that, if you arrange that in your contract. But that's the public cloud. A lot of people are not happy with that. They will prefer to have a private cloud. So this is the old-fashioned model where you just have the old-fashioned model, you'd have a server rack in your server closet, and just the people in your company would connect to your server closet. But if you connect it to the internet so people can connect from a distance, then it's a cloud, but it can be a private cloud where you own the servers, you are responsible for the backups, you know where it is, and the only people you let connect are public company employees and people that can connect to like a VPN. Yes, the private cloud is generally more expensive. Now, technically, with the public cloud, you're just renting servers, but there's a scale issue. Amazon and Google run thousands of servers, so they get very efficient at heating and cooling and backing up and everything. Yeah, the contract is called a service level agreement. Yeah. And so the public cloud is cheaper because you're getting a small fraction of a big server farm, which they're very good at maintaining. In the private cloud, you have to have your own employees that know how to do the heating and the air conditioning and dehumidifying and backup and batteries for power in case the power goes out and all that jazz, and replacing the hardware and repairing it. You know, there's a whole lot of work in maintaining a server. That's why I've talked to students that start companies, and I say, when you buy a server, you made your first mistake. You shouldn't even buy a server. Nobody buys servers these days. You just put it on Amazon. You don't want all this overhead. Whatever you're doing, it's a lot better to just put it on a cloud server and pay a very small rental fee. Then you write your software and run whatever your company is. But the time you'd spend setting up a server farm is almost never justified when you're a starting company. It only becomes justified when you've grown to such a scale that you really have so much traffic that you could use a whole server room for your own traffic. Anyway. So, and even then, a lot of people prefer to just use the Amazon cloud and not have to bother with all that server maintenance business. Now, Amazon had some images that you could use on their cloud, and they let users upload images. And one of the users put up an image that had a backdoor account. So that was an issue. And this is the point. If you don't install your own operating systems, but you just copy from a list of images that somebody else made, which is what a lot of people do on Docker and in other virtualization systems, then you're copying some machine that somebody else built, and you don't really know what's in there. There could be malware in there. There could be secret functionality, and that has happened. Then there's grid computing, which is where you take dissimilar machines and get them all to work together. SETI at Home does this, Folding at Home. These are volunteer groups you can join, and then your computer spends some of its power solving some other problem, like searching for extraterrestrial intelligence by filtering through radio telescope data. All right. And there's parallel systems are where you have a lot of computers working together to solve a big problem. And in this case, they share memory together. Yeah, a Bitcoin mining. Yeah, Bitcoin mining pool. It's probably a fair comparison to a grid computing, although most of those are now identical hardware just to make them faster. How does image incorporate malware when we download? Well, if you download an image and just run it, like for example, Kali. I use Kali in a lot of my classes. And if you go here, Kali VM download. There, right here, the official Kali Linux downloads. You can go here and get a VMware image. If you download this and unzip it, it's a whole virtual machine. And it's got software installed on it, and you didn't install it. So you don't really know what's in there. This could have a listening process with a known password or a weakness or something. That's what it is. You download this thing, you run it in like VMware Workstation, and now you have a virtual machine to use, but you don't really know what's in there. That's what I'm talking about. If you started from, say, Linux and installed it, and then you installed packages one by one, you would know what was in there to a greater extent. But really, anytime you install anything, you're trusting somebody. If you do apt-get to install something, you're just loading some software from somebody else, and you don't know what's in there either. So if you just go to some web page and download something and run it, you don't really know what's in there either. So this is a deep issue, the supply chain weakness in security. No matter what you do, you're trusting a bunch of other people. And since the big SolarWinds hack, I think everybody is getting very worried about how do you really know that software you're installing is genuine and not tampered with. And it turns out there is no good way to know. But people are developing techniques to at least enumerate it all and make sure that it's all up to date, for example. That would be one thing you could do. But to make sure that nothing bad is in there is quite difficult. Anyway, all right. So a parallel system can have a lot of computer processors working together, but they share memory. That can introduce race conditions. If there's memory and one processor writes something, and then before it comes back to read it, some other processor wrote something else on that same spot, then you have a race condition where you can do something that violates the security policy by winning the race. Then there's peer-to-peer. Another BitTorrent is an example here where you want to download a file like a movie, but you don't download it from one server. You just download it from a bunch of people. You connect to maybe 100 machines, your peers, and you get little pieces of it from each of those 100 peers and then add it up. This way it'll be more reliable. If some of the other machines are down, you can just replace them with other different machines and you still get the network, the file. It's hard to stop. You can't block it easily by taking down one server, but it also means you have to trust all those little shards. Now BitTorrent has hash values for each shard, so you can verify that they haven't been modified. But in fact, Tor is a similar issue. Yeah, Tor is bouncing your data off many servers to conceal your physical location. And BitTorrent is just downloading something from not one source. I was surprised years ago that Microsoft didn't use BitTorrent for some Microsoft Update, because then they wouldn't have to have a server that can handle all the traffic. You'd just release it and it would percolate from one machine to another. They do use BitTorrent for Linux downloads these days. But anyway, this is peer-to-peer sharing. Now Microsoft has updates over. I've heard about it. Never do they did. I know. Yeah. A shard is just a little piece of a file, but it's a piece in a proper protocol like BitTorrent. It is a piece and there is some metadata that says what the hash value should be. So when you download one shard of a file, you can verify that it's accurate before accepting it. Yeah, that's good. Just logically, there ought to be a BitTorrent option for Microsoft software updates. Did SolarWinds infect Apple PCs? It's a good question, and I don't know. I thought it was just Windows software, but I haven't looked into it. It's proprietary software, so I can't get a copy to play with. BitTorrent, that's what BitTorrent does. If you run a BitTorrent client, you send out signals. I don't know how it finds the other users, but it does find them. And it then connects to them, and you ask for, so you have a movie that might be 600 megabytes, and you download little chunks of it, like half a megabyte. You say, do you have chunk number 45? Does somebody have chunk number 46? Does somebody have chunk number 47? It's a whole bunch of separate requests for all the little chunks, and those go to random people in the network. And so you just combine it from all these little pieces. That's how BitTorrent works. And once you've got it, then you start offering to share it, and then other people start requesting from you. And that's the point. You can now share something big, like a movie or a Linux distribution, from peer-to-peer, and nobody has to run a central server that can handle all this traffic. You get a copy and you share a copy with somebody else, so nobody has to have a lot of bandwidth. A delivery optimization. Oh, good. Thank you. Good. Delivery optimization in Windows 10 lets you download these things with torrents, apparently. I've heard talk about it. I didn't know they ever got it working. They say I have a lot of viruses. Well, on BitTorrent, files do tend to have viruses because you can share a poisoned file. And then the BitTorrent protocol will not know that. It will just make sure you got an intact copy of a poisoned file. That's the problem with BitTorrent, is most of the content is stolen. So you're dealing with criminals, and a lot of them just put malware in it too. So if you do BitTorrent, you have to be careful about security. And of course, every company will block BitTorrent, both to prevent all the network bandwidth it uses up and to prevent the legal liability of having stolen property going through your network. So thin clients are computers where the actual entire computer is running on a server and you're just looking at it with sort of a viewer. This is what Microsoft Remote Desktop Protocol does. This is really considered quite good at a high security shop. You run just a computer with a web browser, but none of the data is ever really living on your machine. You're just viewing it on a server that's far away, so I can put security controls on the server and encrypt it and back it up, and none of it is ever on your home machine that you might be using to go play games and get infected with stuff. So this is called a thin client, when your computer is really nothing more than just a viewer and a network connection to see data that's somewhere else. And you can also run diskless workstations where you don't even have a hard disk at all on your machine. All it has is a network connection and a keyboard and a mouse. And when you boot it up, it gets the information from the server, and that's all it is. You never store anything. There isn't even any storage device here. Yeah, that's Citrix Virtual Desktop Computing. Yes, that's a thin client, what you're describing. And it might be a diskless. That's what it is. And these things are all the rage. We have regular talks from a guy from FireEye, Stephen, and he said people would hire you right away if you knew how to set up these things in the Azure cloud, because every company wants this. Now, because of the pandemic, everybody's working from home, and they really don't want people putting company data on some laptop in their home. And so what they want to have is this cloud computing where the Windows 10 desktop is in the Azure cloud and you're just viewing it from your untrusted home computer. A Raspberry Pi is just hardware for a very cheap computer. That's all it is. Deck and Son used to have these. Yes, all these things have been around for many years ago. Yes. When I started, this is how it was. You had server clients. We had one computer. It was an IBM mainframe, and all you did was connect to it from a terminal, and all it would do is send characters one by one to the mainframe and get characters back. Yeah. Tails is just a highly secure operating system. I think it's Tails. No, it's Cubes. I think Tails is just an operating system that includes Tor. I'm kind of vague on what it is. One of my students set it up one time. Yeah. But Deck and Son used to have these server client systems. Good. I'm not quite sure what Tails is. It's supposedly a very secure, very private Linux operating system that always runs over Tor and has other privacy features. One of my students set up a machine with Tails one time for a person who was being stalked and hunted and harassed, and they really needed a high degree of privacy. Anyway, then of course there's the Internet of Things, all these little devices with computers in them, like light bulbs and thermostats, and they tend to be manufactured to be very cheap and to run on very weak hardware, so they tend to be really bad with security. They have default passwords, old versions of protocols, no way to update them, no way to turn off the listening processes, and so on, and it's led to a whole lot of network attacks over the internet where people take over these vulnerable Internet of Things devices. There's no reason why they have to be insecure. It's just that when you make them fast and cheap, they tend to make them insecure. Anyway, let's take a look at some cahoots, which I've got here. So 3D is here. There we go. Cahoots are faster in Zoom. Yeah, there's a lag on Twitch. So Twitch provides a lag, but it lets me reach. Anyway, I have to use Twitch on my system. Zoom doesn't work on my Mac. Yeah, there's a lag. But I lengthened the time to compensate, so I guess it's all right. All right, I got 28 people in Twitch. I'll give it a few more seconds to see if more people are joining. Apparently not. Okay. All right, if you want TC-Sec level A, what do you need? Okay, you must have a reference monitor. That's required to maintain the security policy as the various users use the machine. All right, which one is a security risk of virtual machines? Okay, that's VM escape. Okay, kind of obvious. When an attack leaks out of the virtual machine and takes over the host. What is Canvas? It is software as a service. You're running one program and you just have to run that one program. You have no option to do anything else. All right, what system combines dissimilar computers together? Okay, that's grid computing. All right. So I got some winners. All right. All right, well, one of them looks like a real name anyway. All right. Joseph is both are, I guess. All right, looks like someone's saying that equals someone named, okay, Joseph. All right. I've recorded what information. I see someone tell me who they are. Good. All right, so I know who Blothar is and I know who Kahoot is, so I guess I got them all. All right, so let's see. Okay, we can carry on with another bit here. So, vulnerabilities. Emanations is the radio signal emitted by the hardware. This Tempest project was a military project to see how dangerous this was, and it turned out to be extremely dangerous, especially in the days of those CRT monitors. But even now, you can pick up key presses from a keyboard. You can deduce what's on the screen from the radio signals emitted. So the only way to be safe is to be like in a metal basement with no windows. If you're worried about this, all these electronic devices emit radio signals, electronic signals that can be used to deduce secret information like cryptographic keys and what's on the screen. Covert channels in general are communication channels that leak information out that are not being controlled and that are not obvious, so that you don't think you're sending data to a third party, but they're sneaking it out. There are storage channels where you store data in a file somewhere and somebody else can see it, or maybe just the file size, and you can put data in the file size. There's timing channels. This is a big problem with encryption. You can often deduce something about the cryptographic key from the time it takes to encrypt data. And by sending millions of requests and timing them very precisely, you can deduce a lot of information about a key. That's why people try to write cryptographic software that is constant time. So it always takes the same amount of time to do an encryption, no matter what the key is, but that turns out to be difficult to do. Backdoors are unauthorized ways to get in. For example, an extra user account and password that is not controlled by your security policy, or a maintenance hook. This is something that a lot of companies still do. If you might call them and say, I forgot my password, and call the help desk and let's say, oh, we have a secret password so we can get back in. They often have these in. They ought to be used only during development of the system and removed before they ship the final product, but a lot of products get shipped with these backdoors in them. It's a very common flaw. I see the vulnerability reports all the time. I think Cisco made this mistake at least 6 times in major products in the last 2 years, where there was an unauthorized extra account with password in the stuff they were shipping. And then, of course, all the malware that infects your machine, the software that does something rotten. Zeroday exploits are the most dangerous. This is where there is an attack and it is not known to anybody. It's not published in the magazines or in the security community, so nobody knows how it works, so it's not going to be stopped by your antivirus. There's not any patch. There's no update to stop it. These things are very valuable. The security agencies and military hoard them and use them to attack their enemies. And they can come in and there's nothing you can do to stop them, really, because you don't know how the attack works, and neither does your operating system maker or your antivirus maker. Nobody knows about it, so these are just wide open doors to take over other people's systems until somebody finds out and then patches it. So viruses were originally code attached to executable files. Then there were macro viruses that run inside Microsoft Office documents, boot sector viruses on a floppy. So if you boot from a floppy, you get infected. Viruses that hide from antivirus, viruses that mutate, so that they, even if antivirus catches them, they mutate, so they slice past it again. And multi-partite viruses that spread many ways, like through file shares and email, and TFTP. Worms are things that propagate without being attached to a file. This is what almost all modern attacks are. Viruses that live inside executable files are pretty much been over for 10 or 20 days. A Zeroday does not necessarily control your root system. A Zeroday just means that it is an attack which nobody knows about. The reason they call it that is they count the number of days since the patch came out. So a 1-day attack is a day after the patch came out. A 30-day attack is 30 days after the patch came out. This is how your company can decide when to patch. But a 0-day means nobody is ready for it. And there is no patch available anywhere for it, so there's no way to be ready for it. And a 0-day could in principle do anything. There are 0-days that are just denial of service attacks. There are ones that are remote code execution. There are ones that just allow some minor action of limited value. But they're a 0-day if nobody knows how to stop them, if nobody knows how they work. That's what it is. A 0-day is just a secret attack. That's all it is. Anyway, so Trojans are things that lie about what they do, like the Trojan horse. So they tell you it's a game or a security patch, but it's actually something else, like a backdoor. Rootkits are the ones you were referring to there that control your root system. Rootkits replace part of the kernel in most cases. Some are ring 3, but therefore they take over the machine at the lowest level. So they are the most difficult to remove and the most difficult to detect. So now they change the way your system scans through the disk entirely, is a very common activity. So now if you just try to make a list of all the files on your machine, it will not look in a certain folder. So when your antivirus tries to scan every file, it will not be able to find that folder. So your machine now has things going on that you cannot see and you cannot detect and you cannot remove. That's what rootkits do. One way to think of them, the most dangerous rootkit is the so-called blue pill that turns your machine into a virtual machine. And now there are other things happening below it that you can't see. That's essentially what they do. Packers are things that compress a file or change it so that the executable file does not map directly to the file in RAM. And so UPX is one we're using in the malware analysis class. And so when you load a file, normally it takes the hard disk file and copies it into RAM and runs it. But with UPX, the hard disk file is compressed. And when you load it, it unpacks and puts the unpacked data in RAM. So the RAM image does not match the disk image. So when they scan disk image, what's that mean? They copy all the files? No, what they do is read all the files. When your antivirus scans your disk, it reads the file and then compares it to a list of viruses to decide if it's a known virus. And it has to read every file on the disk to do that. But if you have a rootkit, it will not be able to find some of the files, so you won't see it. There are defenses against rootkits, but they're not very strong. It depends on how good the rootkits are. Some rootkits make mistakes, so they can catch them, and sometimes you can catch them before they're installed, and there are file integrity systems that try to make sure no system files have been modified. There are some defenses against rootkits, but they're none of them perfect. Anyway, so you can have packed files, and you can have logic bombs, which are really scary and almost completely undetectable. Your network administrator runs your server, and they can do things like schedule an update. The file that compresses zip files recursively, I don't know about that. I know self-extracting, there's a zip bomb. Is that what you're talking about? Will that be on YouTube? I don't understand what Levon is asking, and I really don't understand the file that compresses zip files recursively either. You're probably talking about a zip bomb. A zip bomb is just a file, and if you make a normal file and then you zip it, it will get smaller. But if you go into a binary editor and write a zip file, you can write a zip file which will unzip to an unthinkably huge file, like 1 billion gigabytes. That's what a zip bomb is. It's a file which if you try to unzip it, it will just fill the whole drive and crash. Yeah, you can Google for solutions for rootkits. There are some rootkit defenses. I used some of them years ago. They weren't very effective. I'm not sure what the modern defenses are against rootkit, but none of them work for you. You got zip bombs. There's also fork bombs. Fork bombs are similar. Fork bombs are files that when you run them, they fork and make another process and another and another until they use up all the RAM. So these are, you know, like little bombs you put on a file system, so when people try to process them, it will cause some kind of problem. If under Linux you mount file systems as a read-only file system, would that protect that part of the file system? I think it would, but you can always change those permissions. And that's what we do in the exploit development course. You can, there are some RAM regions that are not executable, for example, in the Windows system, but you can just run malware that turns off that defense. I mean, that's the problem. If software defense can just be turned off. So it's not an extremely strong defense. Now, if you ran from hardware that was read-only, like a CD, that would be a strong defense against a rootkit. But it would slow down your operating system. But that's one thing. I mean, if you're running from a read-only operating system, then you know nobody's been messing with it. All right, now a logic bomb, if you think about what a server does, it, I see another question I'll answer for. Go ahead. Malwarebytes, as far as I know, does not block rootkits at all. I think all Malwarebytes blocks is PUPs, potentially unwanted programs, which run, they're not, I don't think it blocks rootkits at all. I'm not even sure if modern antivirus blocks rootkits. I think the big ones like McAfee and Norton probably do something to try to block rootkits, but I don't know how effective they are. You can turn on read-only permissions for a file in the file properties in Windows, and you can do it in Linux too. And you'll see how to control the permissions of memory segments in the malware analysis course. There's Windows Virtual Protect is one of the Windows API calls that does it in Windows. Good. Anyway, logic bomb is some kind of program that just waits for a certain condition and then does something. These are around all the time, like periodic reports, periodic updates, and things like that. But you can make a malicious one, like your administrator could write one that every time the paychecks come out, it scans the paychecks, and if I'm not getting a paycheck because I've been fired, then it erases everything. This happened to Fannie Mae, the big mortgage broker. Somebody put a logic bomb on their server, and somehow they found it. I don't know how you find it, because it's not a known virus, it's custom code, and it's not that different than something a normal administrator would do, but those are called logic bombs. Antivirus we've talked about. We all know things like Norton and McAfee and Avast. This is software that runs on your machine, and every time you try to use a file, it checks the file to see if it's known to be a virus. The most common thing it does is just look for a signature. It has a list of series of bytes for all the known viruses, and it checks to make sure it's not on that list. This is what's normally done because it's usually extremely accurate. If it tells you it found a virus, it really found a virus. It does not have a false positive, which is what you really hate, when it tells you there's a virus on an innocent, harmless file. That is considered very annoying, and they want to avoid that. Now, the problem is, if you have a mutating virus or a zero-day attack, it won't be on the list of known antiviruses. So for that, it has heuristic-based, where it tries to look at the behavior and decide if the behavior looks suspicious. And in practice, this sensitivity of this is usually turned down very low because this can easily flag on innocent files and irritate people. Yeah, I don't run antivirus on my Mac. I never have. The only time I ran antivirus on my Mac was to make it a target for an attack, because Sophos antivirus about 10 years ago was so terrible that you could take over the machine right through the antivirus. The antivirus has its own vulnerabilities too. But no, I don't run AV on my Mac. As far as I can, you should definitely run AV on Windows or Android. But I don't think it's worth running on a Mac or on, especially on OS 10, on iOS. Some people like to run it on a Mac, but I haven't been. So server-side attacks, you'll have a server like at a bank, and your server will do something like have a SMB file sharing turned on. So you upload a malicious file. And by the way, you should never do this. You should never let SMB file sharing on port 445 go through your firewall, because it's not safe enough. If you want to share files, you should do it with a HTTP server or an FTP server or something. But anyway, if you do, people can attack the listening port, and they can find a malicious network traffic that will take over the machine, and there are in fact a bunch of those for SMB. Client-side attacks are where I trick your laptop into downloading an evil file like a PDF file, which when you view it will take over your machine, and that happens all the time. PDF files, Office files, and so on. If you don't keep everything updated on your laptop, this is a very common way to take over machines, to get people to download something, and when they run it, it has unexpected effects. Why do you not run AVM? How that cause Oh, yeah, antivirus is, well, the antivirus, I don't know. Antivirus definitely causes vulnerabilities. Antivirus has an attack surface, and there are quite a few vulnerabilities found in antivirus. The most common ones are privilege escalations. There was another one, here's one that came out just a few months ago. If you run antivirus, it will take any file that it determines to be malicious and copy it to the some isolated region, the quarantine region. And then you can delete the files in the quarantine region. And it turned out you could put a shortcut to a different file in that folder, and the antivirus would follow it and delete that file. And the antivirus runs with system privileges, so even if you don't have system privileges, you can delete a file with system privileges by going through the antivirus. That's probably the most common problem. The antivirus is running a high privileged process, and it turns out they have frequently failed to consider the real security consequences of that. There were also antiviruses that ran updates, and you could trick it into loading the wrong code for the update, and then it would run that with high privileges. So, antivirus is just more software running on your machine, and it has had flaws. That's not why I don't use it. I don't use it because I just can't be bothered. But it certainly is true that antivirus does increase your attack surface, but it also stops the viruses. So most people agree it's better on Windows or Android to really run antivirus because it will do more good than harm. But it does do some harm. And anyway, so you can have active content on your web page. And if almost all web pages are active content now. So if you have a PHP page, you very often have something like this. You go to index.php, and then you have a parameter, which is the name of the file. So it will load this file and show you the contents of that file. And when you have a file name in a parameter, you can often replace that with a path. This would be remote file inclusion, where you load that file from a different server. So now the content from that web page will come from somewhere else. And you can also have local file inclusion, where I refer to a different file on the same server. Both of those are violations of the security policy. Then there's executable code you put on web pages that run on your browser. In Java or ActiveX, or in the old days Flash, you'd have these platforms where compiled code runs in your browser on your machine. And the point of this is you can have fast performance, so you can run something like a virus scan from inside a browser, or have a beautiful graphic like a game playing in the browser. But of course, the power of these things made them more dangerous. So OWASP is the Open Web Application Security Project. It's an open source group, and they found what the vulnerabilities are of web applications, and they rated the top 10. It's one of their most famous products. And the number one has always been code injection, SQL injection, and other things, the most common vulnerability. And there are a lot of others, like insecure direct object reference, where you have things on the website that are not public, but you don't actually check the permissions. You just hope nobody will find it. That's why Google will often find things on web servers that shouldn't be there, and then you can find it. And cross-site request forgery, for example, stealing a cookie so I can get in somebody else's account. And here's the one we've been talking about a lot, supply chain vulnerabilities, using components with known vulnerabilities, where your software loads libraries and they load other libraries, and somewhere along the line, one of those libraries is out of date. So now you're running the old version of something. So this is, we talk about it a lot in 129S and some of the other classes. This is for web applications. This is a very good project to enumerate all the vulnerabilities and explain them, and have code examples to explain how to improve your software to avoid these vulnerabilities. XML is just a way to encode data. HTML that you use for web page is a subset of XML. XML is the general way of encoding any kind of data with ASCII text. And service-oriented architecture is where you just have a lot of services. This is what some people call this serverless computing these days. You don't run a virtual machine. You just have a listening process on a cloud service like Amazon or Google Cloud, and it will listen for something, do some kind of calculation, and give you the results. So, of course, it is running on a server, but they don't think of it as being a whole server. It's just a little application running. OWASP doesn't. The thing about OWASP is it will show you how to prevent it. If you go here, it will have example pages for Java and C and other languages showing code examples to show you how to prevent these things. So if you wanted to stop cross-site request forgery, the way you do it is every genuine request, you include an extra parameter that's a random number, and you verify it. So if somebody else tries to use, for example, a cookie, they won't have the other data they need. So it will realize it's a fraudulent request. All right. Anyway, so you've got it's called service-oriented architecture, where you just have these little services responding to input. And you have web services. They take data in a variety of formats. You can take it as XML, or you can take it as JavaScript notation, just a different way to lay out the data. And then you can use SOAP or REST. These are two different ways to send requests to a server that then give you a response. I see a question, there is a finite amount of injection attacks. Well, I don't know about that. But the most common one is SQL injection, but you can also have other kinds of injection in different languages. I don't know, injection is any time that some data you type in can be misunderstood as a command on the server side. In a way, all buffer overflows are code injections if you want to look at it that way, although you usually think about it differently. But technically, a buffer overflow is a code injection at machine language level, whereas SQL injection is a code injection at SQL, and command injection at the bash command prompt is at the bash level. I don't know. There's XML injection. I've done that. There's a lot of them. Pretty much any language that you parse has a possibility for injection. Anyway, they also use web service description language. This is a language that's used to find out what services are offered by a web server. So databases store a bunch of data. Like you have all the names and addresses and social security numbers of all your customers, and that is then you have software that runs queries to the database. Like Facebook has a giant database with everybody's account and password and all their Facebook posts. And when you go to your own Facebook wall, you log in and it shows you just your information. Now I can show you the SQL injection. I'm getting a lot of people want to see that. All right, if I've got it here in quite a few of my classes, like it's in 127. If you haven't seen SQL injection, you definitely should. So here's SQL injection. I can search for people by name. So if I search for Bill Gates in this database, then it finds Bill Gates. And here's the code that does that. Select name from the table named employees, where name equals Bill Gates. That's SQL. This is the language that's used to fetch data from a database. Now, if I put an apostrophe in this, then I have a problem. Now I get an error in my SQL syntax because the apostrophe that I typed matched this apostrophe that the developer put there. So now this becomes name equals Bill, and after that, this Gates is expected to be another SQL command, and Gates is not a valid command. So this is SQL injection. Part of the name I typed in was misunderstood as a command on the server. So now all I have to do is learn this language called SQL, and I can inject valid commands and execute them on the server when all I was supposed to be able to do was put in a name. So I can do something like this. It didn't copy. Let's try it again. Copy, I say. Okay. All right. And now it gave me a 1, so it executed this command, select 1. And I put that inside a name, but the server misunderstood it to have the name stop here and the command happen there. So now I can execute commands on the server. Now this command just prints a 1 on the screen, so it's not very harmful. But there are more dangerous commands, like this one will give me a list of all the table names, and this one will give me all the column names. So I can execute that command on the server, and now I get a list of all the columns in the table named employees. And so now that I know there's a column called SSN in the table named employees, I can select SSN from employees. So let's go here. There. There, this is what people do. Now I get all the social security numbers out of the database. And the only thing the developer thought I would be able to do was look for one person's name. That's SQL injection. This is the most common kind of command injection, where some kind of innocent data, like a username or a password, can contain commands and they get executed on the server. That's a really big vulnerability. It's very easy to exploit, and it's very common. Something like 11% of websites have that vulnerability. And it means you can frequently steal all the data on the server, and sometimes you can even take over the operating system on the server. Yes, it can be that simple in real attacks. It can be even simpler because there are automated tools that will do it for you, to where you don't even need to understand it. There's one called, there's SQL Map is the professional one, and there's another one called Carrot in Arabic. I forget the name. There's a bunch. You just run a tool, and it just automatically steals all the data from the server. Yes, you trick that name into executing a command. Havij. Havij is the tool that does it easiest. It's a Windows tool, and if you run Havij, it will just dump the data off the server. Yeah, so if you see that error, it usually means people can steal all the data. There's a bunch of, so a lot of people, this is what Anonymous did years ago. They stole all this data from Sony and stuff by using these very simple attacks. Anyway, so that's a database. Now, there's another kind of vulnerability in databases called inference attacks and aggregation attacks. If I have a database and it has high security data and low security data, I mean high classification, like top secret data and unclassified data, then I can try to deduce it. And that's what these attacks do. These attacks try to deduce high privileged data by reading only the low privileged data. Now, primary key is a field used to uniquely identify the records, so usually use social security number or a student ID or something like that, so you can tell people apart, even if they happen to have the same name or the same address or something. Polyinstantiation is a system where you can have two rows with the same primary key, but they have different data for each clearance level. So the top secret people will see all the data, but people with secret clearance will see only part of the data. This is a way so that the people with a lower security level will not see data missing. This is one of the attacks. You try every possible value of the primary key, and the ones you can't see, those must be the top secret ones. But now that attack wouldn't work because you will see some information for every value of the primary key, and you won't know that there is more information that is beyond your clearance. So inference and aggregation are the two attacks. Inference is where you infer something from lower level information. This is something people have told me that is really true. If you were in Washington, D.C., near the Pentagon, and there's a lot of pizzas ordered at night, that means there's a major military activity underway, and they're making everyone stay late, and they order pizzas. So a low, unclassified process, like how many people are buying pizza, gives you a clue about a high classified process that you shouldn't be able to know about. And aggregation uses many low-level facts to deduce the information, like you go through a phone book and you try every phone number, and some of the numbers are not there, and those are the high privilege numbers. That's the sort of thing. So if you want to prevent this, you could make pizza orders restricted information, put your pizza vendors under NDA, so the pizza vendors for the Pentagon promise not to tell people how many people are buying pizza, and that's part of the deal, whereby I guess you'll probably pay a higher price for your pizza to get that service. Polyinstantiation prevents inferences because you will not find any missing phone numbers. You'll get some data for every phone number. And restricting the number of queries made is another way. So you're not allowed to ask about every phone number. You can only ask about 10 an hour or something like that. All right, anyway, this gets you into the world of data mining, which is a huge issue. The internet is the prime example. The internet has tons of data, and somewhere out there is everything you want. Every terrorist threat, everybody's password is on there somewhere. Every customer that wants to buy your product is on there. Whatever you want, it's somewhere in that data if you could only find it. So that's called data mining. Trying to find the information you need from a large pile of data. And data analytics is another part of this, where you try to analyze the data to discover things. One really popular thing these days is to try to find out who in your company is disloyal because of Edward Snowden. Edward Snowden was a trusted military contractor, and he took the data and leaked it publicly. So then every top executive asked their staff, how do we know that one of our staff is not going to turn traitor like that? And the answer is you don't, but now they're selling software that will try to watch your network traffic on your network and try to predict who seems to be disloyal, who's showing up late, who's spending more time on Facebook, who's downloading more forbidden stuff like porn at work, and therefore they're disloyal or something like that. Try to somehow detect this. That's one form of data analytics. So countermeasures against data, against these sort of things, you can have multiple overlapping controls to stop people from getting where they shouldn't go. So you have technical controls, like they have to log into a certain account to get there. And then you have policies and procedures that limit what people do. And then you have physical controls, like locks and guards. And all these make layers of defenses so that hopefully if one security measure is overcome, there is another security measure that might still prevent the abuse. Mobile devices create a lot of problems. People bring in USB devices and thumb drives, and they can bring in malware. They can also put secrets on them and use them to exfiltrate data, which is what Snowden did. He copied the data onto a CD and carried it out. I thought that was Bradley Manning who did that. Anyway, so you can limit your mobile device activities with a policy, or you can have technical controls that don't let you plug in random USB devices. They force you to use devices that have a special signature put on them. This is my official company USB stick that will be encrypted, and I can't just use any random USB stick. And if you want to, now people can steal your portable devices, like your phones and iPads, and there are countermeasures. The first thing is you just don't want to lose the data on the device, then you have backups. And if you don't want the bad guy to get the data on the device, then you have full disk encryption and remote wipe, so they won't be able to read the data, and you can remotely wipe the data to take it away. These are all ways to prevent the bad guy from getting the data on the stolen device. I got one more Kahoot, and there's another section after this, but I might not do that tonight. We'll see. But we're up to 3E, which is here. All right. Oh, I see a question over here. Yes, infected files can live on a Mac and be passed to a PC. That's happened, they pass through iPhones, for example, when you synchronize music. That happens. An antivirus on the Mac, it might stop that. I know some of it does. I'm not sure it all does. It's a good question, and I don't really know the answer. I've heard people say that ClamWin does what you just described, but I'm not sure if other Mac antivirus does that. Sure, good question. All right, give it a few more seconds. All right, so okay, what does the FBI want on the iPhones? Yeah, what they want is backdoors. They want to be able to read the data on the iPhones, and they made a big deal fighting with Apple about it. Dodan, you've got a point. I've never caught a virus with ClamAV either, because ClamAV does not do real-time protection. It just scans things. So, yeah, ClamAV is not a very effective product if you want to protect your computer. It's got a different purpose, really. So what threat destroys a system on a certain date? Okay, that's a logic bomb. I see a question how to put a backdoor on an iPhone. It's extremely difficult because typically you can't put any software on the iPhone except from the Apple Store. So only very advanced people can do it on the iPhone, and I've never done it. I know it can be done. I know the military can do it, and there are some ways. But if you jailbreak your iPhone, then it's pretty easy because then you can put in software from unexpected sources. Yes, and there have been times when you could exploit the browser in older versions of iPhone where you could jailbreak. But yes, these answers are good. Coming through the App Store is nearly impossible. And most people only put on software from the App Store, so it's really quite difficult. You have to find a fundamental flaw in the iPhone operating system, and although those exist, they sell for $1 million or more these days. They're not publicly available. We will play with iPhones in the mobile device hacking class, but we're going to jailbreak them. And then they become vulnerable because you can put on unauthorized hardware, software, but that is not the way most people's iPhones are. Anyway, this thing is a logic bomb that would wait for a certain date. Oh, I have to hit a button. All right, what language tends to have LFI vulnerabilities? Okay, that's local file inclusion, and it's a property of PHP. And I see someone mention the Clipper chip. The Clipper chip was just a cryptographic chip, but it used the vulnerable version of encryption. So the government wanted them to install it in devices, but it turned out to be a bad idea because it did DES encryption. All right, so what organization publishes the top 10 vulnerabilities? Okay, that's OWASP. Good. All right. All right, and what attack searches a large database for useful information? Yeah, that is data mining. All right. All right. Okay, Garcia, I've seen that before. All right, and JC. All right. I'm going to stop this recording.